to AMK Resource World. Your success, our motto. In this video, we are going to learn about the equivalent circuit for the diode. Okay, let's talk about diode equivalent circuit. So, what do you mean by equivalent circuit? So, if we are building the behavior of the device or a system using electrical elements like voltage source, current source, resistance, capacitance, inductance, whatever. So here exactly imitating the behavior or approximately imitating the behavior of a device or a system using the elements other than the device is known as equivalent circuit of that device or of that system. You can see here we have three approximate models for the equivalent circuit of the diode. First one is ideal model, second one approximate model, third one piecewise linear model. So here we have three models using which we are representing the equivalent circuit for the diode. So coming to this ideal model. So in this ideal model, the forward voltage drop and the forward resistance are not considered. Therefore, Vf is 0 and Rd is 0. So if Vf is 0 and Rd is 0, then you can just see how the plot or how the characteristics will look if we plot them. You can see here. So here it has been plotted a line which is exactly at the origin. Why? Because it has no slope, that means no resistance, and it is not towards the positive voltage because the voltage is 0. It is exactly lying at 0. Okay, so this is the ideal characteristics of a diode for ideal model. And if you want to represent that diode as an ideal diode, then it's nothing but a short circuit where we have no voltage drop and where we have no resistance through that. Okay, so now coming to this approximate model. In approximate model, we are considering the forward voltage drop, but we are not considering the forward resistance. So the forward resistance is 0. So if you take a silicon diode, the forward voltage drop is 0.7. So here, if you plot this, if you plot the forward characteristics for this approximate model, where we have considered the Vf forward voltage, but we have not considered the forward resistance, then you can see here, it's a straight line exactly at 0.7 volts because we have considered the forward voltage drop, and Rd is not considered, because of which we don't find any slope here in this line. The slope of a line is due to resistance, but here we don't have resistance. Resistance is 0, so here we don't have the slope here. It's a straight line. Fine. So let us represent the diode with the equivalent circuit using this approximate model. So according to this, the diode can be replaced by a battery of 0.7 volts, which will make a drop of 0.7 volts, which is acting as a forward voltage drop of the diode. So this is the equivalent circuit for the approximate model of the diode. Okay, now coming to piecewise linear model. See, in this piecewise linear model, we are considering both the forward voltage drop as well as we are considering the forward resistance. So therefore we have written here the forward resistance is not equal to 0, right? So you can see here, when we plot the characteristics for this piecewise linear model, then we find the line at 0.7 volts, that is the forward voltage drop, and it has a slope which indicates there it has a resistance, right? So if you replace the diode with this equivalent model, then we have to replace the diode with a battery of voltage Vf and a series resistance, variable resistance Rd, so that it completes the behavior of this diode, which is the equivalent circuit for the diode according to piecewise linear model. Guys, if you like our video, please like, share and subscribe. We will be bringing more such videos relevant to your topics in our channel AMK Resource World. Your success, our motto.